All right, so guess what? We're going deep today. Deep into information theory. But hold on, this isn't going to be all like equations and formulas and stuff. We're talking about like information itself, you
Yeah.
know? How do we even measure it? How do we share it? And get this, how our brains might actually be using it. Ever heard of Claude Shannon?
Oh, yeah, of course. Practically the godfather of like the whole digital age.
Yeah.
His work, I mean, think about it. It helped us shift from those like clunky old analog signals
Yeah.
to the world we live in now, digital communication.
It's kind of wild when you think about it. Like, where would we even be without the internet, smartphones, all that, even just digital
Sure.
music? It all goes back to Shannon's work, you know, information theory. Okay, so let's like break this down. One of the like foundational ideas here, the bit. So what is a bit exactly? And how does it connect to this whole information thing?
Okay, so think of it this way. A bit, it's like the atom of information. The simplest possible like distinction, like a light switch, on or off, right? That on or off, that's your bit. A 1 or a 0. And from that tiny little building block, we build like entire universes of data. Text, images, music, you name it.
Okay, so it's like a code then, a way to represent any kind of information using just ones and zeros. But then how do we actually measure how much information is in something? Like, can we say that this news article has more information than like that tweet?
And that's where Shannon like blew everyone's minds. He realized that information, it's not just about like the number of bits, it's about reducing uncertainty. So the more uncertain you are about something, the more information you get when you actually learn about it.
So if you told me like the sun's gonna rise tomorrow, that's not a lot of information, right?
Yeah.
Well, it's pretty certain. But if you told me you won the lottery yesterday, that's a whole different story.
Exactly. That's a ton of information because it was so unlikely. And that like surprise factor, that measure of uncertainty, that's what we call entropy.
Now, I remember seeing this formula for entropy and like the stuff we read. It had something to do with probabilities and logarithms.
Right. The formula can look a little scary, but the idea is actually pretty simple. Let's use like flipping a coin as an example. So if the coin is fair, 50-50 chance of heads or tails, that means maximum uncertainty, right? Maximum entropy. You can't predict what's going to happen.
But if the coin was rigged to always land on heads, there'd be no surprise at all, so the entropy would be 0.
Exactly. And that's where it gets a little weird. Maximum entropy, that means maximum unpredictability. The more random something is, the less we know about what will happen, and the more information we actually get when we see the result.
So a fair coin toss, that's actually more informative than a rigged one. Huh, that's pretty interesting. But how does entropy, this measure of surprise, actually apply to like the real world, besides predicting coin tosses? I mean,
Right. One of the most like practical applications is in data compression. So the more predictable a piece of data is, the lower its entropy, and the more efficiently we can compress it.
okay, so that's how we fit like thousands of songs on a tiny little device. But walk me through that a little more. What does entropy have to do with making files smaller?
Okay, so think about it this way. The English language, it has a lot of structure and patterns. We use the same words over and over again. And some letter combinations, they're way more common than others. This built-in predictability. It means that written text has relatively low entropy. And by using these clever algorithms based on information theory, we can like exploit those patterns to represent the information in a way more compact way.
So you're saying that understanding entropy, it lets us make our files smaller and transmit information way more efficiently. So that's why we can stream like high definition movies on our phones without needing like a hard drive the size of a refrigerator. That makes a lot of sense. But are there other applications of this entropy idea?
Absolutely. Entropy, it's everywhere. It's in understanding language patterns, analyzing DNA sequences, even cryptography and artificial intelligence.
Wow. So this concept of like information as a reduction in uncertainty, it's really powerful. It seems like it's got implications for like so many different areas.
It does. And speaking of different areas, one of the things we read mentioned these Hopfield networks. They're used to model associative memory.
Wait, so like how our brains might work? Now this is where it gets really interesting.
Exactly. Think about like how you can remember a song from when you were a kid, just by hearing a few notes. Hopfield networks, they try to model that kind of associative memory, where one piece of information triggers like a whole chain of related memories.
So these networks, they're like a simplified model of how our brains might store memories.
Yeah. And the crazy part is, we can analyze these networks using concepts from information theory.
So as the network learns, it becomes more organized, less random, and its entropy decreases, kind of like how our brains get more efficient at processing information as we learn new things.
That's a great analogy. It suggests that there might be these deep connections between the principles of information theory and how our own minds actually work.
This is making me think. Are we basically just biological information processors? Are all our thoughts and feelings just this complex dance of bits and entropy?
That's a question scientists are still trying to figure out.
Oh.
The human brain, I mean, it's vastly more complex than any computer we've ever built.
Yeah.
But the idea that we can use information theory to unlock some of its mysteries, it's incredibly exciting.
It really makes you wonder if information theory can be applied to digital signals in the human brain, where else could it be relevant?
That's a really fascinating thought, and that's exactly what we're going to explore further in our deep dive.
I'm already hooked. But before we go too far down that rabbit hole, let's take a step back for a second and talk a bit more about that fundamental unit of information, the bit. We talked about how it's like a switch, but how do we figure out how many bits we need to represent something? Like, does the number 8 take the same number of bits as the word cat?
That's where logarithms come in. It's like a yes-no question. So to figure out the bit length of something we ask, how many yes-no questions do we need to pinpoint that piece of information?
Okay, so for the number 8, the first question could be, is it bigger than 4? The answer is yes. Then is it bigger than 6? Yes again. Is it bigger than 7? No. So it took us 3 questions, 3 bits to get to the number 8.
Exactly. And that's precisely what our source material means when it says the bit length of the number 8 is 3, because 8 is 2 to the power of 3. It takes 3 powers of 2 to reach 8.
So finding the bit length, it's all about finding the right exponent, the power of 2 that equals our number. But it's not just about numbers, right?
Right. This concept applies to any type of information. The more possibilities there are, the more bits you need. Think about the English alphabet, 26 letters. To represent each letter uniquely, you'd need enough bits to cover all those options.
So if we used a simple code where A equals 0, B equals 1, C equals 2, and so on, we'd run out of options before we even got to Z. We'd need a more complex system with more bits per letter.
Exactly. And that's basically how digital encoding works. Finding clever ways to represent complex information, using combinations of zeros and ones.
This is all starting to click. But I have to admit, I'm feeling like my brain is reaching maximum entropy here. It's incredible how much ground we've covered already. From the basic definition of a bit to the mind-bending concept of entropy and its role in data compression.
It is quite a lot to process, isn't it? And you know that feeling of your brain getting full, it actually ties back to information theory too. Our brains, they have a limited capacity to process information at any given time.
So you're saying there's a limit to how much information we can take in. Like our brains have a Shannon capacity too.
That's an interesting way to think about it, and it highlights why it's so crucial for us to focus on the most relevant information and filter out all the noise. Otherwise, we get overwhelmed and can't make sense of anything.
Which is probably why I'm suddenly craving a giant slice of chocolate cake. Maybe my brain needs a sugar rush. To process all this information theory goodness?
Perhaps. But speaking of processing information, we are starting to touch on this idea of the brain as an information processor. And that brings up some really fascinating questions about how our brains might use concepts like entropy and information to learn and make decisions.
Right. We talked about hot field networks earlier, but I'm still not totally clear on how those relate to our actual brains. Can you unpack that a bit more for me?
Of course. Remember hot field networks. They're a type of artificial neural network. Computer systems that are inspired by the structure of the human brain. They're made up of these interconnected nodes, kind of like neurons, that can store and retrieve patterns.
So they're like simplified models of how our brains might store memories.
Exactly. And what's fascinating is that we can analyze these networks using concepts from information theory. For example, researchers have looked at how the entropy of a hot field network changes as it learns new patterns.
So as the network learns, it becomes more organized, less random, and therefore its entropy decreases. Kind of like how our brains become more efficient at processing information. As we learn new things.
That's a great way to put it. It suggests that there might be these deep connections between the principles of information theory and the inner workings of our own minds.
This is blowing my mind. So you're suggesting that our brains might be using algorithms similar to those found in artificial intelligence.
It's a possibility that some scientists are exploring. Of course, the human brain is infinitely more complex than any artificial neural network we've created so far. But the idea that information theory could provide a framework for understanding both biological and artificial intelligence, it's incredibly exciting.
It really is. And to think it all started with Claude Shannon and his quest to understand how we communicate. Who knew that his work would lead us to ponder the very nature of consciousness itself?
It's a testament to the power of curiosity and how seemingly abstract ideas can have profound implications for our understanding of the world.
Well, I'm officially hooked on information theory. And I have a feeling we've only just scratched the surface. What other incredible insights are in store for us on this deep dive?
We've covered a lot of theoretical ground today, but next, I think it's time to explore some of the practical applications of information theory, from how it shapes the technology we use every day, to its potential to revolutionize fields like medicine and even art.
Sounds like we're in for quite the journey. I can't wait to see where information theory takes us next.
It's amazing to think about, isn't it? This like invisible force shaping how we communicate, how we store data, maybe even how we think.
It really is. Okay, so we've explored some pretty heady concepts, but let's bring it back down to earth for a minute. Talk about some real world applications of this information theory stuff. You mentioned earlier that it plays a huge role in the technology we use every day.
Exactly. And one of the most obvious examples, it's right there in your pocket, in your smartphone, your laptop, everywhere, really. Remember data compression. It's information theory at its finest, making those massive files smaller so they can zip across the internet and fit onto our devices.
Oh, right. Like how I can have my entire music library on my phone without it turning into a brick. But to be honest, I never really thought about the how. I just assumed it was some kind of digital magic.
Well, there's definitely some clever engineering involved. But at its heart, data compression. It's all about exploiting patterns and predictability. Think about a streaming service like the one you probably use for music. It has to send huge amounts of data to millions of users at the same time. If they sent every single bit of information in those audio files, it would totally cripple the network.
Okay, that makes sense. So how do they use information theory to avoid a global internet meltdown?
They use these things called compression algorithms, which are basically like mathematical recipes for squeezing out redundancy. Remember, the more predictable something is, the lower its entropy. So these algorithms, they analyze the audio data, they identify patterns and redundancies, and then they find clever ways to represent that information using fewer bits.
So they're kind of like digital Marie Kondos,
Right.
tidying up our data and getting rid of anything that doesn't spark joy.
That's a great analogy. And it highlights how information theory helps us do more with less. We can transmit information more efficiently, store more data in the same amount of space, and ultimately make our technology faster and more powerful.
It's incredible to think that this seemingly abstract theory has such a tangible impact on our daily lives. What other technological marvels can we thank information theory for?
Well, consider error correction codes. These are essential for making sure that data is transmitted and stored reliably, even when there's noise or interference. We're talking about everything, from the data on your hard drive to the signals beamed back from spacecraft billions of miles away.
Wait, so information theory is helping us talk to robots in space? That's even cooler than digital Marie Kondo.
It is pretty cool. These error correction codes, they work by adding a bit of redundancy to the data. It's like packing an extra suitcase when you travel, just in case one gets lost. But instead of packing extra socks, we're adding extra bits of information that allow us to detect and correct errors that might occur during transmission or storage.
So it's like a safety net for our data, making sure it arrives intact, even if it has to travel through a cosmic storm of interference. But how does information theory help us design these error correction codes?
It provides the mathematical framework for understanding how much redundancy we need to add, what kinds of errors are most likely to occur, and how to design codes that can correct those errors efficiently.
So it's not just about making things smaller, it's also about making them more robust and reliable. Information theory really is the unsung hero of the digital age.
It really is. And its applications extend far beyond the realm of computers and communication. We're seeing information theory being used in fields like medicine, where it's helping us analyze complex biological signals, like brain waves and DNA sequences.
Wait, so information theory can help us understand our bodies better? How does that work?
Think about a doctor trying to diagnose a patient based on an EKG reading. That EKG, it's a stream of data that contains information about the heart's electrical activity. By applying information theory, we can extract meaningful patterns from that signal, filter out noise, and ultimately get a deeper understanding of what's happening in the body.
So it's like a doctor having a secret decoder ring for our biological signals. Are there other ways information theory is being used in medicine?
Absolutely. It's being used to develop more sensitive diagnostic tools, personalized treatment plans, and even design new drugs. Some researchers believe that information theory could play a key role in understanding and treating diseases like cancer and Alzheimer's.
That's incredible. It seems like information theory, it's not just about bits and bytes, it's about understanding complexity and finding patterns in chaos, whether it's in a computer network or the human body.
That's a great insight. And its applications extend even further. We're starting to see information theory used in economics to understand market behavior, in social sciences to analyze communication patterns, and even in art to explore the concept of information aesthetics.
Information aesthetics, that sounds fascinating. What exactly does that mean?
It's a relatively new field, but it's all about how information shapes our perception of beauty and meaning in art. Some artists are even using algorithms based on information theory to create new forms of art that play with concepts like entropy and complexity.
So you're telling me that information theory can help us understand not just how we communicate, but also what we find beautiful. This is blowing my mind.
It is pretty mind-blowing, isn't it? Information theory is a powerful lens through which we can view the world, helping us make sense of everything, from the tiniest microchip to the vastness of the universe.
It really does feel like we've unlocked a secret code to the universe. But before we wrap up, I'd love to loop back to something you mentioned earlier. Our brains as information processors. We've touched on how information theory is being used to model memory, but how else might it help us understand the complexities of the human mind?
That's a great question, and one that scientists are actively exploring. One area of research is focusing on how our brains use information to make decisions. Every choice we make, from what to eat for breakfast to which career path to pursue, it involves weighing different options and assessing their potential outcomes.
So are you saying that our brains are constantly running these complex algorithms, calculating probabilities and minimizing uncertainty, just like a computer program?
It's certainly a possibility. Some researchers believe that our brains might be using principles of information theory to make decisions that maximize the amount of information we gain or minimize the potential for surprise.
That's fascinating. But our brains aren't just cold calculating machines, are they? We have emotions, intuition, creativity, things that seem far removed from the world of bits and algorithms.
You're absolutely right. The human brain is far more than just a data processor. But even our emotions and intuitions might be rooted in information processing, albeit on a subconscious level.
So you're saying that even our gut feelings, those seemingly irrational impulses, could actually be the result of complex calculations happening beneath the surface of our awareness.
It's an intriguing possibility, isn't it? And it highlights just how deeply information is woven into the fabric of our existence.
This is incredible. I feel like we've only just scratched the surface of what information theory can tell us about ourselves and the world around us. Where do we go from here?
Well, I think it's important to remember that information is everywhere. It's in the words we speak, the books we read, the music we listen to. It's in the patterns of nature, the movements of the stock market, even the randomness of a coin toss.
So you're saying that information theory, it's not just some abstract concept confined to the realms of science and technology. It's a lens through which we can view and understand everything around us.
Exactly. And the more we understand about information, the more we can appreciate the intricate beauty and complexity of the world we live in.
I couldn't agree more. This deep dive has been a real eye-opener. But I have a feeling there's still so much more to discover. What other mind-blowing insights await us in the world of information theory? All right, round 3. Let's do this. We've explored all the theory behind information theory and how it's being used to model all kinds of things, from computer networks to the human brain. But where else is this theory making a splash?
Well, I think it's safe to say that information theory is having a pretty big impact on almost every field you can think of, from the technology we use every single day to the way we understand the universe itself. The principles of information theory are helping us unlock all these new possibilities and solve complex problems.
So it's not just about the ones and zeros, it's about like a whole new way of thinking.
Exactly. It's about recognizing that information. It's a fundamental building block of reality, just like matter and energy. And once you start seeing the world through that lens, a whole universe of possibilities opens up.
I'm starting to see that. But I'd love to hear about some concrete examples. Where is information theory having the biggest impact right now?
As we've already talked about, it's playing a huge role in how technology is evolving. Everything from the smartphones we carry around to the algorithms that power the internet. They're all built on the foundations of information theory.
Right. We talk about data compression and error correction codes, which are super important for making our technology work smoothly. But what about some of the more cutting edge stuff? What's on the horizon?
One area where information theory is going to have a major impact is in artificial intelligence. As AI systems get more complex and sophisticated, We need new ways to understand how they learn, how they make decisions, and how they interact with the world.
So you're saying information theory could be the key to unlocking the full potential of AI.
It's definitely a possibility. By applying the principles of information theory, we can get insights into how AI systems process information, identify potential biases, and design algorithms that are more robust, reliable, and transparent.
That makes sense. But what about other fields besides technology? We talked about medicine, but are there other areas where information theory is making a difference?
Absolutely. One really cool application is in economics. Economists are using information theory to understand how information flows through markets, how investors make decisions, and how prices are set.
So it's not just about numbers and spreadsheets anymore. It's
Yeah.
about understanding the role of information in shaping how people behave in the economy.
Exactly. And it's not just about traditional markets. Information theory is also being applied to behavioral economics, which explores the psychology behind economic decision-making.
It seems like information theory is everywhere. It's like a universal language that connects all these seemingly different fields.
That's a great way to put it. And it's not just about understanding the world around us. Information theory can also help us understand ourselves better.
Oh, how so?
Because we talked about earlier, our brains are incredibly complex information processors. By applying the principles of information theory, we can get insights into how we learn, how we remember, how we make decisions, and even how we experience emotions.
So you're saying information theory could be the key to unlocking the mysteries of consciousness itself.
That's a question that's been puzzling philosophers and scientists for centuries. But I do believe that information theory can give us a powerful framework for understanding the mind and its relationship to the physical world.
This is also incredibly fascinating. But I have to ask, with all its potential, are there any downsides or limitations to information theory?
That's a great question. Like any powerful tool, information theory can be misused or misapplied. For example, in the wrong hands, it could be used to manipulate people, spread misinformation, or even create more effective surveillance systems.
That's a bit of a scary thought. It seems like with every new technology, there's always the potential for both good and bad.
That's true. But I think the potential benefits of information theory far outweigh the risks. By understanding the power of information, we can use it to create a more informed, more connected, and more equitable world.
Well said. This deep dive has been a truly mind-expanding journey. We've explored the fundamental principles of information theory, its wide-ranging applications, and even its potential to help us understand consciousness itself. I have a feeling that we've only just scratched the surface of this incredible field.
I agree. Information theory is still a relatively young field, and there's so much more to discover. Who knows what breakthroughs and innovations await us in the years to come? But one thing is for sure, information theory is a powerful lens to view the world through, and its influence will only continue to grow in the future.
Well, there you have it, folks. We've journeyed from the humble bit to the frontiers of consciousness, all thanks to the power of information theory. It's a field that touches every part of our lives, from the technology we use to the way we think and create. So next time you send a text or stream a movie, or just marvel at the complexity of the world around you, remember the invisible force of information. That makes it all possible. And as always, keep exploring, keep questioning, and keep diving deep into the fascinating world of knowledge,